Hello friends, welcome to the video lecture series on machine learning. So from this lecture onwards, we are going to learn about the individual tutorials on a different machine learning algorithm. So we will start with k nearest neighbor classifier. So let's see what we are going to learn in this lecture. So in this tutorial we are going to start with a very basic example to give you a glimpse of what this nearest neighbor classifier, how it is useful in a real world application, what is the exact problem definition. We'll define a very formal way the problem of nearest neighbor classifier, then we'll go for the naive implementation in a Python of this nearest neighbor classifier, then the same implementation we'll go with the scikit-learn implementation, and then we'll see is there any optimized algorithm which will reduce the complexity while searching for the nearest neighbor in this multi-dimensional hyperplane. Okay, so let's start with the one very simple example, and let's try to put or let's try to correlate those example with the help of nearest neighbor classifier. Okay, so let's just consider this digit data set. So this is one of the very famous MNIST digit data set. This is also called one of the hello world application of the neural network or machine learning also. So in this data set we have been given total 10 classes of category. Each class contains a different image of different digits. So the class 1 contains almost 7 different instances of image 0 digit. The class 2 same contains 7 instances of digit 1. Now in the case of nearest neighbor, what is our task is, suppose we have given one test image which looks like 6, because for human it's very easy to understand. So in case of nearest neighbor, our task is to find what are the images which is the most near to this image in this multi-dimensional space. So suppose our nearest neighbor algorithm has found this 3 nearest neighbor which is very near to this one. So that is what called the nearest neighbor with respect to this test image out of this whole multi-dimensional space of all different instances available. So all of the machine learning algorithm you can correlate with this neural network classification, or this way nearest neighbor classification or nearest neighbor matches. Let's take one more example of Google search or even Amazon product recommendation system. So in a case of Google search or product recommendation or a product searching, you giving the query and what this services will return, this will return the top 10 matches, which is nothing but the nearest neighbor with respect to your query. Out of all products are available or out of all links are available inside the Google index data set. So that is how the nearest neighbor works. So this is very informal way or intuitive way of understanding what this nearest neighbor algorithm is. Then let's try to define a very formal definition of nearest neighbor. So let's just concentrate this two-dimensional space. So this space has some data set which is having having a 2 dimension. Let's say this red class of point belongs to this cat category, and this green class of point belongs to dog category. So this set of instances are belongs to the cat, and this set of instances belong to the dog. Now these individual points are just the 2 points, but in reality it can be a 100 or even a 10,000 or even a million point to represent the single image also. Just for the visualization purpose we have projected into only 2-dimensional space. Now let's see how this nearest neighbor classifier problem will fit into this category. So these are some of the feature associated with this nearest neighbor. So in our case of nearest neighbor, this is kind of very lazy learning kind of model. So this is all our features, or even a pixel you can consider as a feature in case of this image. So in case of this nearest neighbor, this feature itself are the training model, so there is no training required for the case of this nearest neighbor classifier problem. So whole training time has been reduced to 0. Only testing time will remain, as we have seen in a earlier lecture, that for all machine learning application everything is been divided into two steps. Either in a offline mode you do training, and in a online mode you do kind of testing. But this is one of the unsupervised way of learning problem. So there is no training required. You just need to search out of all possible value and matches with the test dataset available. Most of the time we'll use this Euclidean distance to measure the similarity with the test dataset with the help of all other training dataset available. So this is all about the training. So training is not required, so all those datas are available itself is your trained model. Now you have all the trained model. Suppose you have been given a new image which looks like a cat, and your job is to find which are the most nearest point out of this multi-dimensional space. Out of all images are available, individual points is nothing but one image. Actually that point is the representation of this image. So what this nearest neighbor classifier will do, it will try to calculate this new test dataset, distance between this new test dataset with each and every other point available inside the training dataset, and whatever the nearest distance are there, that will be classified as a nearest neighbor with respect to this test dataset. So in this case it looks like a cat, so whatever the point which are nearer to the cat class, it will classify as a nearest neighbor, whereas those point which belongs to the dog class, which is much more farther away from the cat category. Now let's put some vicinity of circle. So in our case we have defined a problem with respect to the k nearest neighbor. This k can be anything, it can be a 1 or 2 or any odd number. So in case of this k is equal to 3, that means the with respect to this data set we have a 3 points which is we quite nearer to the test data set. So these 3 points will be classified as a nearest neighbor with respect to this test data set. This circle is not up to the mark, it looks like that these 2 might be the most nearest, but anyhow just for understanding purpose I have kept the circle. So in the vicinity of this circle, this 3 point lies, that is called the nearest point with respect to our test data set. And out of that nearest point, which point belongs to which class, the majority vote will win. So in this case all 3 points lying into red class. Red class is nothing but the cat class, so we will classify this image or this new test image has been given into the cat class. So that is how the nearest neighbor searching will works. So in a next lecture we'll see about, we'll generate some random data inside the Python, and we'll try to apply this Euclidean distance way of measure on the top of this data to find some or implement the very naive approach of nearest neighbor classification. Then we'll go with some standard dataset like a Boston dataset or Iris dataset that we have seen in earlier lecture, and with the help of scikit-learn library we'll try to implement this nearest neighbor classifier. So I hope you enjoy listening this video. Please do like, comment and subscribe it.